Good morning to you all, students. So without wasting time, I would like to proceed with the previous chapter, that is matter in our surroundings. So students, we have studied in the previous class, we discussed about the effect of temperature in the change of state. How the temperature, it changes the state. How the variation in the temperature brings change in the state. Now students, we have discussed in the previous class about latent heat of fusion, latent heat of vaporization, and students, this is a new thing for you. So whenever anything new is taught, okay, just revise it once. Okay, so to have a better understanding, otherwise other portion you will not understand. Okay, particles in the steam at 373 Kelvin. 373 Kelvin is equal to 100 degrees Celsius. Okay, if you have to change Kelvin to Celsius, you have to subtract 273, and if you have to change Celsius to Kelvin, you have to add 273. So particles in the steam at 373 Kelvin or 100 degrees centigrade have more energy than water at the same temperature. Why? Because these particles in steam have absorbed extra energy in the form of a hidden heat. Okay, in the form of a hidden heat, or we can also say latent heat of vaporization. So yes students, by the change in temperature, the state of matter can be changed from one form to another form. Now you see the image in the slide or the document, or refer figure 1.7 of your book. Now students, you take camphor or ammonium chloride. Ammonium chloride is a white solid powder or camphor. Okay, now you crush it and put it in a china dish. Okay, now over china dish you keep inverted funnel, and the funnel will have opening at the top. That opening you close with a cotton plug. Make one plug of cotton and close it. Now you heat it. Okay, what you will observe? Record your observations. You will observe that solid ammonium chloride or camphor, it will directly change into vapor. Okay, and when this vapor will come in contact with the walls of the funnel, okay, it will change back to solid ammonium chloride. This process is called as sublimation. Okay, this you have done even in class 6 I think. Okay, a change of state. Now here the state is changing. How? Ammonium chloride was solid, one state, and on heating it changed into gaseous state. Okay, so here the solid is changing into gaseous. One state is changing into another state. So a change of state directly from solid, that is ammonium chloride, to gases without changing into liquid state is called sublimation. Here from solid directly it's changed into gas. But in case of water, when you melt, if you melt ice, if you increase the temperature of ice, it will melt to water, and when you will heat water, then at boiling point water will change into steam. Okay, and the change of gas to solid without changing into liquid is called deposition. Okay students, now today we will learn about effect of change of pressure on change of state. How the change in the pressure affects the change in state, whether the state is changed from one form to another or no. Okay, so we will see how the pressure also affects the change of state. Now students, we all know that the states of matter differ from each other due to the difference in space between the particles of matter. You have studied before, we have learned that between the different states, in the different states, the particles have spaces, but in some state like gas, the particles are far from each other, the space is more compared to liquid. And in liquid, the space is much more, between the particles is much more than that of solid. So what happens? If the space is increasing, the force of attraction is decreasing, and if the force of attraction is less, particles can move freely. Okay. Now, in solid state, the particles are very close to each other. In case of liquid, particles are far from each other. If they are far from each other, they are pulling each other with less force, so force of attraction is less. And in gaseous state, they are very, very far from each other, and because of that only, the force of attraction is negligible. Now, students, what to do in order to bring these particles closer to each other? How? Let us take the case of gas. Now, what should be done so that the particles in the gas come together, closer to each other? If the pressure is applied in the particles of the gas, what will happen? Pressure or force is applied. In the gas particles, the particles are very far from each other. Now, if the pressure is applied on the particles of gas, what will happen? The particles of gas will come closer to each other, and they will occupy less space. What will happen? If you are applying force on the particles of gas, the particles of gas is coming together, and there is change in the state. The gases changes to liquid, because you know in liquid the space is much less as compared to gas. So what happens? Gas particles are very far. Gases are occupying lot of space. So when the pressure or the force is applied, the particles of gas will come closer to each other. They will occupy less space, and when the particles of gas will come closer to each other, what will happen? The gases, it will start liquefying, because in liquids the particles of liquid, they have spaces between them. I hope you are understanding this. So on applying or on increasing the pressure and on reducing the temperature in the gases can be liquefied. Okay, why gases can be liquefied? Because you know in the liquid state the particles have space between them. Okay, now in gaseous state particles are far from each other, the space is there. Okay, and what happens? In order to bring them close together, what happens? If you apply the pressure, the particles of gas will come closer to each other, thereby changing the state. Okay, or you can say gases can be liquefied on applying the pressure or on decreasing the temperature. Now children, solid carbon dioxide. What is solid carbon dioxide? Carbon dioxide is a gas. So solid carbon dioxide means it is in a solid state. Now, carbon dioxide gas, you know carbon dioxide gas, so since it's a gas, particles are very far from each other. Okay, there are large spaces between the particles. Now when in this solid carbon dioxide gas, when the pressure is applied, what happens? It changes into solid state. So gas, carbon dioxide gas is stored under high pressure. So what will happen? That gas, carbon dioxide gas will change into solid carbon dioxide. Why? On applying high pressure, the particles will come closer to each other and very less space will be there. Forces of attraction will be more. What will happen when the particles will come closer to each other? It will be like the arrangement of the particles in solid state. So it will change into solid state. So this is called solid carbon dioxide, which is also called as dry ice. I hope all of you have understood. So temperature and pressure determine the change of state of a substance. Okay, understood all of you? Now students, you all know evaporation. Actually, what is evaporation? What do you understand by evaporation? Now we all know that water changes into vapor at boiling point. Okay, when water is changed, when water is heated at boiling point, what happens? This water changes to vapor. But can you give any example or can you quote any example from our everyday life where change of state from liquid to vapor takes place without the liquid reaching the boiling point? I hope all of you have understood. What happens? Water changes into gas at boiling point, but do you know any change in everyday life where the state can be changed or liquid can be changed into water without liquid reaching the boiling point. I hope all of you have understood. At boiling point, liquid changes to steam. But are there any examples where the liquid changes into steam much before boiling point is attained? Example is wet clothes dry up. In order to dry up the wet clothes, what happens? You dry up wet clothes. So there the clothes, they dry up. The water changes into gas. Okay? How the water changes into water, that water of the dry clothes will change into vapor form or no? Okay? So here the boiling point is not reached, because here the water of the clothes, it changes to vapor much below the boiling point. And when the water is left uncovered, what happens? The water on the surface of the particles on the surface of the water, what happens? They gain water from the surroundings and overcome the forces of attraction with other particles and change into vapor. I hope all of you have understood. You are understanding this or no? Okay. Now children, you know that the particles of matter, whether solid, whether liquid, whether gas, they are moving. In solid, the movement is very less, but in other two states, they move. In gases, they move freely. And so if they are moving, means they are having kinetic energy. So particles on the surface of water is also having kinetic energy. So the particles which are present on the surface of water, they take energy, they take heat from the surroundings, or they take energy from the particles of water from other side. Okay, what will happen? The kinetic energy will increase and they will change into vapor state. I hope all of you have understood. Okay. Now, the phenomena or the process of change of liquid into vapors at any temperature below boiling point is called evaporation. Here the water particles, they take energy. Okay, the kinetic energy is increased. They take energy, means they take heat from the surroundings. So heat is a form of energy. So when they are taking heat from the surroundings, their kinetic energy is increasing, and with the increase in the kinetic energy, they overcome the force of attraction with other particles and they change into gaseous state, because even in the gaseous state also the particles, they move freely. I hope all of you have understood this thing. Now children, what are the factors which affects the evaporation? What factors affect the evaporation? Increase in the surface area. If the surface area is increased, if you take water in a test tube, and on the other hand, if you take water in the china dish, the water in the china dish will evaporate more as compared to water taken in the test tube. That is why in order to dry the clothes, what we do, we spread it out. So on increasing the surface area, the evaporation increases. Second, on increasing the temperature. On decreasing the humidity. What is the humidity? The amount of water vapor which the air can hold. So if the humidity is less, if the surrounding air has less humidity, means it has less water vapor, and it can hold more water vapor. So that increases the rate of evaporation, increase in the wind speed. Okay. Now student, evaporation always causes cooling. How? Now if you have taken water in an open vessel, the liquid evaporates. Slowly it changes into vapor, because as I told you, the surface water has surface particles on the surface water has kinetic energy, and it takes the energy from the surrounding particles also, heat from the surrounding particles also, or from the surroundings, not only particles but from the surroundings, it takes the heat, and on taking heat, again the kinetic energy increases and it changes into vapor. But since it takes the heat from the surroundings, it produces cooling. I hope all of you have understood this thing. Okay. Now student, two portion short portion is left that you will read for homework, because this we have done. Even I think in class 7 I have done why we should wear light color clothes in summers and dark colored clothes in winters. So we have already done this thing. So please revise these two portions. Why should we wear cotton clothes in summer, and why do we see water droplets on the outer surface of the glass container in ice cold water? Understood? So this portion you read it, and with this I finish chapter 1. Okay. Now I may give you few question and answers, or I may give you assignment. So whatever I give you, after hearing the audio, you have to write in your copies. If I give you question and answers, that also after hearing the audio, you have to write in your copies. Okay. If I give you assignment, then assignment questions you have to do. Is it clear? Okay. Thank you, students.